This is the t43 method. It's like an improved version of it, which lets you deduce more ions from the periodic table, and you only need the right side of it. So let's start. So basically, you just draw t43, hence the name t43, and just do -3, -2, -1. Do the same here: -3, -2, -1. So first things first, we want to look at the elements in the first symbol. So carbon, we know carbon, nitrogen, and silicon, so we do carbonate and nitrogen, so nitrate and nitrite. Next, silicon, silicate. Finally, we can do hydrogen carbonate, which will be a recurring theme for the next one. And if this seems kind of tough, just do it a few times. You'll get a handle of it. You'll get a handle of it. It's not too bad. Carbonate is just CO. T stands for 3, so CO3 minus 2. Minus 2 is from here. It's like rows. Same with nitrate. Nitrate would be NO3 minus 2. But for nitrite, we need to remember that nitrate to nitrite, you lose that oxygen. So NO2, keep the charge. And for silicate, it's just SiO, and silicon is -2 and 3. For hydrogen carbonate, you literally just slap an H in front of the carbonate. So, well, not actually though. With one more step, we gotta remember that H adds a positive, so -2 plus 1 is just -1. Next, we gotta do the next one. So for phosphorus, phosphate, phosphite, and sulfate, and sulfite. Phosphate, we could do PO4, right? 4, PO4, charge is -3. Whoops. Okay. And then we lose one. We lose an oxygen. So PO3, keep the charge. Sulfate, SO4, and -2, right? Sulfur. And same thing, SO3, we lose an oxygen because sulfite, -2. Next, we can do the hydrogen versions of these. Or I don't know if that's the term for them, but that's what I'm going to call them, because there's just a hydrogen slapped in front of them. So hydrogen phosphate is just HPO, not -3, because we added positive, so -2, 4. We don't do hydrogen phosphite, but we do dihydrogen. I'm not sure if you're supposed to capitalize that, but dihydrogen phosphate, and we just do 2, di means 2, so H2, PO4, -3 plus 2, -1. Next we do hydrogen sulfate, which is just HSO4 -1, because like I said, we add a plus to the minus, and hydrogen sulfite, which is just HSO -3, because -2 plus 1 is just -1. Next we look at the last symbol, and that's a 3, so we can do chlorate, but for this one, we can think of chlorate as like a base, and we can deduce chlorite and hypochlorite and perchlorate. And sort of like sulfate, chlorate is our base, so we look at 3 chlorine, So ClO3 minus 1. And we do the same as we did here. We just subtract an oxygen, ClO2 minus 1. And you don't really need a 1 there, you just do negative. But, and say ClO4 minus 1, and ClO minus 1. Next we can do bromate. We can do the exact same thing. So it's just bro, base, bro, negative 1, 3, 2, 1, and 4. We can also do another one. We can do permanganate, chlorate, right? You can sort of think of, I don't know, for this one, for perchlorate, you can think of permanganate. For perbromate, you can think of permanganate because this is the only one where we use per in. So permanganate, I don't think I spelled that correctly. And it just MnO4 minus, because, sort of here, we used a 4 here, and it's also the same charge. So relatively easy to remember. And we can also do iodine or iodate, right? And iodate also works. We could do 3, O3 minus 1 charge. And that's it.